you Dr. Rupen Goswami for the excellent presentations in the morning as well as in the afternoon, who enlightened us on the revisions of code and what is going to happen, so that we got some glimpses. Now we are running short on time, so I request all the delegates, we have a break for only 10 minutes, so please have a tea and immediately come back. We'll have the panel discussion on 16700. Please. So I request the panelists to come to the stage. Madam Alpa Sheth, Dr. Rupen Goswami, and Anil Hira. So I will just briefly introduce the panelists today. Alpa Sheth is Managing Director of EMS Consultants Private Limited. She is currently convener of Tall Building Subcommittee of CED 38, Bureau of Indian Standards. She has been seismic advisor and consultant to states of Gujarat, Maharashtra, Delhi, Jammu and Kashmir, and undertaken post-earthquake reconnaissance survey studies also. She is a founding trustee of Structural Engineering Forum of India, that is SEFI. So a lot of discussions are happening on this forum, you must be aware. You can join this forum, that is also free of cost. She has been involved in design of over 200 tall buildings and holds a postgraduate degree in structural engineering from University of California, Berkeley. Welcome, Alpa Madam. Introduction about our second panelist, Mr. Anil Hira. Anil's professional expertise is in tall building design and complex structures and architectural engineering, with particular interest in wind and seismic engineering and soil structure interaction. He has been involved in well over 150 tall towers, over 200 meters in height, including 80 towers, over 200 meters worldwide, including Australia, New Zealand, Southeast Asia, Middle East, and subcontinent including India. He is recognized as a world expert on the structural design of tall buildings. He is a very active member of CTVH also, and they are conducting good amount of workshops and seminars also for the fraternity and structural engineers. So with this, we will start the panel discussion on this code. All the panelists will express their views. And of course, Dr. Rupen Goswami is also there to assist us. You have heard him in the morning and afternoon session as well. We have one mic in the floor level. If you have written some questions, please pass it on to us. Or other panelists, they will express their views on the topic, and then we will take forward discussions. Just to start with some questions and all, I will just have two brief questions. One important thing that is expressed by all the designers is the IS code is telling us to do this, to do that, follow this, comply this and that, which is not in the hands of structural engineer all the time, because architect is a master. He makes the plan very, very complicated for us. Now to have the second mode of torsion or third mode of torsion, that is also very difficult to achieve and comply. So my question is, who will bail the cat? That is, I think someone has to answer that. Maybe we have to go to BIS to do something about that, because unless we have good configuration, we heard in all the morning lectures also, the configuration very, very critical, very, very important. And which, if you don't have any control over that, then naturally we are not able to design or build good structures. That is my perception. So on that, I think panelists can throw some light and what exactly we can do about it. And the second pertinent question is, suppose the building is not complying with the codal provision, that is called a code exceeding building. And there are, I think, certain guidelines and provisions, 1, 2, 3, 4, 5, 6 items. If it is not complying, then that goes to code exceeding structure, right? Then you have to go to that expert review panel, committee and so on, and they may approve. But I don't know. If it is not passing the codal provision, then maybe you have to go to some other expert, or maybe proof checking consultant, we call it. But sometimes you are on this side of table, sometimes you are on that side of table. So you design, I approve, right? I approve, you design. That should not keep on happening. Because they are not, again, going to do some exclusive solution. I don't know how that is to be addressed. Suppose really there are some issues in certain building and structure, and really we know that it is code exceeding or whatever way it is. But how to have good structures in certain situations? Is there any guideline to do this due diligence and all? So that I think people are very eager to understand. from this core committee also. So these are, I think, some of the starting points I am just throwing up for the discussions. Okay, over to Alpa madam.
Good evening. I know that it's a bit late. I think they're very important questions that Mr. Vadalkar has actually raised, and just indulge us a little bit. So before we start on those questions, I think Mr. Anil Hira has a few points which he would like to talk about in response to what we all heard today. So over to you, Anil.
Thank you, Madam Alpa. Yeah, I thought I was a good student out there, and I actually took some notes, and I sort of summarised 7 main points that, I think in my 45 years of practicing engineering, and I still practice engineering, I still design. In fact, that's all I do now, design complex projects. So there's some messages that I thought I'd like to just convey. I'm from that country that was on that slide that showed the peak acceleration at about 2.9. That little country that plays cricket and plays pretty good rugby, New Zealand. That's where I was born, bred and studied. And I studied under Park, Paulet and Priestley, and some of the elderly people here know that they're the gurus of seismic engineering. And I recall Tom Paulet. He never, well, we didn't have computers, so we never talked about elastic analyses or linear elastic or non-linear elastic, because we didn't have computers. We were still solving matrices, right, by hand. But they were leaders in earthquake engineering, and it was all about testing and ductility and energy dissipation and gut feeling, and how you still design, and we still design 20, 30-story buildings in that country where you've got peak accelerations of over, I've forgotten the number now, 2.6 G or whatever it was. No buildings have collapsed in New Zealand in terms of tall buildings. So there's going to be an important message there that I want to talk about. And when you look at the world's seismic events, and when you look at the fatalities, doesn't matter whether it's in Gujarat, Japan, New Zealand, no tall buildings have collapsed. Well, not in New Zealand and not in Japan in terms of a collapse. Sure, they're damaged. And when you look at the fatalities, 95% of the fatalities, unfortunately, are within buildings that were non-engineered. No engineers involved. And we as an engineering profession, we have to deal with that. And so I think we spend far too much energy and dedication on buildings that normally don't fail, even if whether they're being designed correctly or they're being incorrectly designed. They tend to perform a lot better because of the fact that they're down the track in terms of the period, longer period, attract less load. It's the 1 or 2 story residential buildings, the 2 or 3 story shop fronts that fail and kill people. And I think we've got a bit of a responsibility there. The third point, the gap between academia, authorities, practicing engineers and technology is getting bigger and bigger, and that's a big concern. And that's because we don't talk to each other and we don't develop the regulations and the process together efficiently. I feel we're going backwards. The fourth point, the analytical tools. As I said, I was designing 40, 50-story buildings without a computer. Well, tell a lie, with a mainframe computer. Now I can design 100-story buildings, non-linear, 3-dimensional, with the touch of a finger on my laptop, and the answers come out within minutes. The problem is that the tools are getting advanced, but the people that use the tools don't know how to use it, and don't know garbage in, garbage out. And our focus and energy is far too much on the analyses and less on the details. And it's the detailing which is I think where the focus should be in terms of our ultimate objective of safety and minimising fatalities. It's an art. The computer's just a tool. The art and the art of engineering, I think that needs a little bit more experience, and it needs a little bit of interaction between people with experience and the people that are using the tools. There are far too many young engineers that probably want to get into management far too quickly without actually understanding engineering. We touched on what the missing loop in terms of monitoring and instrumentation to get more data. And I think that's a challenge for us as a profession because we've got lawyers and not many people that own buildings want other people monitoring their buildings, but that's a good excuse to take them to court when things don't go right. But I think that's a challenge for us as an industry. The next bit, we are all engineers here. Unfortunately, the outcome and the success of a building is multidisciplinary. And I think it's going to get more and more multidisciplinary. We ignore the architects, really. I don't like having ugly, structurally very safe buildings that are square columns on a 9-meter grid, weak column, weak beam, strong column. I understand all the concepts, but at the end, the success of a building is judged by the mums and dads. And we need to be conscious of that. And especially in the new world, where people are putting more and more focus on social sustainability, we want to be in an environment where we like where we are living. And I think that's going to be very important. Seventh point, my most important point, that no one touched on it. We as a profession are responsible for 40% of the carbon footprint as a construction industry. Not one person mentioned carbon footprint. Concrete and steel is responsible for 40% of the world's embodied carbon, right? And so there's a direct conflict. We don't want our buildings to be safer and safe. We want them to be exactly in compliance with whatever we develop. I'm assuming that all our buildings have been safe from the day one if it's been engineered, right? Now, 100 years later, with advanced tools and that, we should be thinking about optimizing our structures. They should be more slender, they should be optimal, they should be attractive. And I think it's going to be very, very important that it's going to be minimum carbon footprint. And so we need to put that as a factor in codes in terms of measuring the carbon footprint. I think that's very, very important. And the last speaker, we spoke about the retrofitting and in terms of repairing, retrofitting. It's totally, that is going to be the very, very important for our profession. We can't afford to just demolish and rebuild things. Retrofitting is going to be a big item in India because we just don't have the time and the money to replace everything. And so I think that's going to be a big future. So the other points about materials, yes, materials going to keep changing, and whether we like it or not, I think the construction industry globally has lagged behind. We only have to look at the motor car industry and look at what Elon Musk has done in the last 2 or 3 years. And to be honest, I'm a bit progressive, that I see that when you look at all the pictures of the failures, they are the 2 or 3 story buildings. Well, I actually think that they're all going to be built in a factory in another 10, 20, 30 years. All our buildings are going to be built in a factory. Even in India, as the economy gets better and better, labour costs are going to be expensive. China, it's already expensive, and they're automating everything. India, where traditionally labour costs has been cheap, that's why we still talk about reinforced concrete. I think it's going to be all MMC, modern method of construction. In the next 20 years, 30 years, this country is going to see huge changes, and the younger engineers out there are going to be quite different to me. So they were just my thoughts. They're controversial, but they're my thoughts, and I think we can talk about tall buildings now. Thank you.
Thanks, Anil. I think Anil has reflected some of the comments I was hearing even at tea time. So I think he's speaking for quite a few of you over here. And I think it was important that those thoughts and those opinions were articulated. And I think, so we have, I think all of you know that the Civil Engineering Division, or CED, of Bureau of Indian Standards has lots of divisions, CED 1, 2, 3, 4. So the earthquake codes come under CED 39. And special structures comes under CED 38. I'm serving as a chairperson for that since the past 1 year. And we have the privilege, and Anil Hira is also with me on that committee. We had the privilege of having an opportunity to come up with the first tall building concrete code, and then we've come up with a new revision. And really what is interesting, and I think this brings up or springs up a new point which is very relevant to all of you, that our CED 38.5, which is the tall building subcommittee, is essentially comprising of a majority of practicing engineers. And we have academia also, which kind of keeps us on track, in terms of looking at things in a more balanced way. But I think all of us also are very responsible engineers. So if any of you have had a chance, I think most of you have had a chance to look at IS 16700, you would see that it is written keeping the practicing structural engineer in mind, and also giving credence to her or his maturity, his understanding of how structures behave. This code is not meant to be a primer to how to look at tall buildings. It's meant for mature engineers who have some basic and fundamental understanding of structural behavior. And then we are kind of directing them that as far as tall buildings are concerned, here are some parameters. If you follow these parameters, we more or less know that the behavior of the structure is going to be acceptable. That does not mean that if you don't follow all of these parameters, your building is going to be unsafe. It does not mean that at all. It just means we don't really know how the structure is going to behave. Therefore, you need to do far more rigorous analysis. You need to have more eyes on the project, and that's why we have the engineering review panel. I think what Mr. Vadakar said is very true, that if you just have a peer reviewer, it's like, I pat your back, you pat my back, right? And we're going to have a nice little cabal, and I'll peer review your project, you peer review mine, we're one happy family. So that's why what we had originally planned, which is a first of a kind, that the Bureau of Indian Standards code is telling the municipal authorities or the building authorities having jurisdiction that please formulate this kind of a committee which has these skill sets, and let them sit together and review projects which don't follow these prescriptive codes, prescriptive requirements of the code. Unfortunately, that has not happened. However, I think Mumbai has a high-rise committee, and there are, Navi Mumbai has it, and different Pune, so many other, Surat also has started having. So there are some towns and cities in India which have started at least having a high-rise committee, which is some kind of a consolation if till the time you have an ERP. Right, so I think that's a good way to go. I think when you heard this morning what Professor Goswami gave, that there's a possibility your force levels become 1.5 times, 1.8 times, 2 times, 2.5 times, 3 times. I think first of all I must congratulate Professor Goswami, because he's the only professor who has come out and said it as it is. Because there are lots of people who are involved in that code committee, but nobody has been so upfront and said, look, this is going to be the effect, and this is what it is. I think for those of you who are, and as I think what Mr. Anil Hira said, and it's fairly evident to all of you, that in all the earthquakes you've seen starting from the 1980s, that's from when I have been watching earthquakes, And I'm going to take the 2001 Bhuj earthquake and the behavior of structures in Ahmedabad, which were 10 stories and 12 stories, as an aberration. As an aberration because they were semi-engineered. Okay, they were not even fully designed for dead and live. Those of us who've analyzed those buildings know about it. So let's not look at those 10 and 12 story buildings which collapsed as an example that even tall buildings can fail. No, they were not designed for earthquake, that's a different thing, but they were not even designed for dead and live loads. So I think just again to underline what Mr. Hira said is that you have hardly seen across the world in any earthquake tall buildings which have collapsed and lives have been lost. There have been some which have suffered some amount of damage. Some may have even suffered damage which may not be repairable, and that building may have had to come down, but there are a handful of such buildings. But we have looked at that, and in this new revision, what we did is we looked at, and I think some of you have heard me say this before, so pardon my repeating it, but we looked at 10 different codes from across the world, and we said, wait a minute, the empirical formula we have in 1893 code, it really is referring to buildings which are low height buildings. It really is not valid for tall buildings. So that is why, after looking at all these different codes across the world, we came up with this formula, this new equation, which we have incorporated in this revision. And I think that what is going to happen is, even though the IS 1893 with the revisions which will come, and the force levels of Mumbai also may go up by 40% or whatever, you may not, as far as tall buildings are concerned, see a very drastic increase in your base shear. I think that is one thing which is good for you. But I think as far as the shorter buildings are concerned, yes, buildings which are less than 50 meters, you are not allowed to use that particular Codal formula, Codal equation which has been newly introduced. And you will see that 1893 with the new revision when it comes out will cause buildings to be designed for much higher force levels, and also you will have certain challenges in providing the stiffness required for the deformation limits that may come out. So it may be a challenge. I think when it comes, we will have to look at it. And of course, I think that the difference, I think Rupen Goswami, that's something maybe you can answer, is that the divide between academia and industry is something which which needs to be kind of reduced, because most of the people sitting here, and even me for that example, we come across a lot of buildings, and I think even Dr. Aldekar also showed that buildings are falling down without any lateral load. I mean, there's no earthquake which has come or no such thing. They're just falling because of issues of corrosion, poor maintenance, of durability issues, right? And those maybe IS 456 may be looking at it, but are we looking at it in a sledgehammer kind of a way, or are we looking at it in a nuanced way? So that would be also something which people would be looking at. And the other thing which I think is a concern is that, I know that it's not a nice thing to say, but I think a lot of times the codes have to be followed by people who don't have too much representation in the code writing process. So how do you think we can remedy the situation?
Thank you. I don't think there is a gap between industry and academia. We are sitting next to each other. You called, I came, and at least we can afford to have a laugh at the end of a long day. No, I understand what you are saying. So I'll first take it little professionally. So you are aware that at least in CD 39, what has changed in the recent past is that for every item we have a working group of 5 people where there is mandatorily 2 from industry and 2 from academia, and the chair and the convener can be anybody, right? So it is a conscious effort that is being put in today. I agree that probably when we all started 30 years back, it was definitely not the case, and 30 years back, even when I started this journey about 10-12 years back, I was like the only one of my age sitting, and I'm only listening to 50, 60, and so on and so forth. So I was in my 30s sitting there and listening. So I can assure you that things are changing, and we will have lot more participation coming in years to come. I mean, I'm optimistic about that aspect at least. So that's the first thing that I would like to say. With regard to the seismic force issue, I think it is not exactly academic per se, for various reasons. Because this effort, you have been looking at it very closely. Of course, the difficulty here is that there is no answer or no benchmark that is available. You can test a number and say this is the correct number, because there is no such background to it, right? So we have to have some hypothesis, we have to follow standard procedures, and then keep on doing iterations, no, try this, try that, and all that, and it has taken 10-12 years. I mean, today, somehow we have to trust ourselves, and when I say ourselves, it's not me who has done it. I have played no role in that hazard assessment, but I'm willing to trust my colleagues. And if I have not done it myself and come up with another answer to prove the other person wrong, then what option do I have other than to believe that that answer that has come out through a very systematic scientific process is correct, which has been overseen by so many people for so many years, right? So again, on that front also, I would say that let's accept that. Of course, when we accept a change, anything, when we start undertaking a change, there are going to be challenges, there are going to be uncomfortable, situations. I think we can overcome those also in the long run. With regard to structures, collapsing or getting into bad state, even forget about earthquake and everything. Yes, I strongly feel that is definitely a real issue in the country today, right? More than seismic safety, that itself is a real issue. The last meeting we were discussing quality control, quality assurance. I think that is a major issue today in construction, right? So we need to look at that. But that's one aspect of it. The other aspects also we have to. So there are multiple issues here, and we need to work on all these fronts equally. There is no one magic wand which is going to come and solve all the problem, and there is no one issue if we fix, everything is going to get fixed. So that's the outlook I think that we can adopt today, and the only solution to this that I see is that we really need, and I mean it sincerely, we need a lot of participation from a lot of people. I mean, this is the only way we can move forward. About one very important aspect that Anilji mentioned is design using gut feeling. I mean, this is what, in my way, I say that as a structural engineer, you need to understand structural behavior. I think that is what you also intend to say. Your gut feeling tells you this is going to work, this is not going to work, this is how it's going to react to this situation. And that understanding, that development of that understanding is very, very fundamental. So here, I want to talk about these things. One is code compliance. Code compliance is for a large number of people, of engineers, who may not have still developed that understanding of structural behavior. It is for them to ensure that I do all these things. I've done this, I've done this, I've done this. It's not technology, it is technology. I've done this. that is why we need codes and that is why we need standards, because a lot more people are in that group because of various things, including how academia is going, running the country. What we are doing in academia, we have to accept that. Then, once you have done enough number of those technologies, then you start developing, and then you will start talking about, talking about good practices. Okay, code says this, but beyond that, I think we should also do this. Right? So good practices is where some experience, this kind of, and the final level is actually safety. But the point is structural safety is a very absolute, very obscure, abstract kind of a concept. So to reach there, you have to go through these levels, and that is why we need standards to begin with, and they often need to be prescriptive also. So IS 16700 is a classic example where you don't expect a 18-year fresh graduate to come and design a 200-meter tall building. Allow that, right? And so they have come beyond code compliance and already have started understanding structural behavior and have developed a feel for good practice, what is to be done, what is not to be done. Right? And that is where this is the classic example, and that is where we are talking about so-called code accidents. Although there is a strong, belief that code should not talk about code accidents, then there is no need for a code, so to speak. But I guess it's a very, very important document. It's going to be the leader in many such things that may come up in future. So 16700 in that sense is a very important document from that point of view. However, for the rest, I believe we still haven't matured enough to get done with the so-called prescriptive standards that we need to follow in the country, because we need to follow in that. We need little more time for that. Yeah.
Should we open it to the house for questions? We are open to answering 16700 or anything for today.
One question regarding the clause of lateral drift. Hello. Yeah, I have one question regarding lateral drifts. It says that for design earthquake force, the maximum interstory drift shall be h by 250. So when we say design earthquake code, first whether we have to use it scaled up earthquake force, like with the approximate formula, because I believe that it should not be, it should be unscaled, and whether it should be with factor of safety, because this design word is getting, there are a lot of peer reviewers, and this question comes up and pops up again and again.
Okay, so anything, I agree with you that maybe we could be a little bit more clear, and maybe there's ambiguity there, and we'll definitely review that, and we need to see that. But all issues which have to do with serviceability, we only take the serviceability levels, right? So there is no factors which are added to that, right? Now, all the serviceability issues as far as the seismic loads are concerned, for serviceability, there is no scaling. There is no scaling. Now, the reason is that when you are looking at serviceability, you are also looking at the natural period which is given based on the analysis, right? And always what happens is that the analysis will give you a much higher natural period, which means that your building is far more flexible, which means your deformations are much higher, right? So therefore, there is no requirement for any scaling. There is no requirement for scaling to the base shear, the empirical empirical formula derived base shear. And also it is a serviceability requirement, so there is no scaling for the limit factor. Yeah, so that's clear.
This question is regarding the use of different grades of concrete for columns and beams and slab. Now, the code, the way I read it, it seems that in the joints between beams and columns, it is permitted to use the 0.7 times the grade of column, and it is still safe. Now, if that is correct, then when the flexural check happens for the joint, what grade do I consider? The original column concrete grade of column or the concrete grade used in the beams?
Try to answer that. So you're talking about the column, when the column strength is greater than...
Yes, for example, M70 for column and M50 for beams.
Yeah. So for the joint, for the shear within the joint, you have to use what the concrete is in the joint, which is the slab concrete. Yeah. And we're in the instant where you increase to have a puddle strength between the, then you use that concrete strength.
So it's not so explicit, so people tend to actually put the missile of concrete and be done with that without actually doing it.
No, the reason you allow for the column, let's say as you said, the column is M70 and you're using M50 in the joint. The reason we say that you can still continue to assume that the column can be designed only in M70 is because at the joint it has very, very high area of cross section, right? And we can it's only for the actual load, yeah.
Not for the shear.
Not for sure.
Hello, sir. Good evening. I really like the presentation of Professor Rupen Goswami. I have a question. In RC building, how do we determine the yield point in the load deformation curve?
You mean to say for a whole building?
Yes, sir.
Okay. See, you will never get a idealized with an yield point kind of a thing. So you get a nonlinear curve. If you do, for instance, what is known as pushover analysis, you will get a curvilinear thing. And then there are various strategies of idealizing it, and then you can definitely find out a representative yield for that. So there are multiple. You can consider the first yield anywhere in the building to represent the yield. You can even idealize the entire curve and get an idealized, elastoplastic or whatever curve, and then say, okay, this is my representative yield. So its point is primarily to understand where your damage initiation happens, how damage progression happens. If you are trying to estimate ductility capacity, then only you need this. Otherwise, for the rest of the thing, you don't need.
Actually, my question was about ductility only. So
Yes.
I am asking about the displacement ductility demand.
Yes.
So it is the ratio between the maximum deformation divided by the yield displacement.
So do not worry, there is enough uncertainty going to be there in your whole earthquake itself, and that's also aleatoric type. So even a small deviation or variation in your estimate of ductility capacity and precise, there is no precise yield point for a building, for a structure as such. These are all estimates, and even if you have a small variation in that, that's not going to affect the final outcome of your design or anything by that much, because the uncertainty associated with the earthquake is even higher, which we are not even looking at.
Okay, sir. Sir, my next question is about the size of the grid points you considered for the PSHA.
Oh, I believe that is 0.1 kilometer by 0.1 kilometer. Macro zonation, I know people have gone with 50, 100 by 100, 50 by 50, 10 by 10. I think here it was 100 meter by 100 meter, which is 0.1 kilometer by 0.1. And why, in fact, this reminds me that why it was, so important, this study, is that it's not that you and I or anyone here, if we just wish, we can sit down and do. The supercomputer, the parallel computing facility of the institute had to be used on a full, continuous basis to do such analysis. So a humongous amount of work that had to be done. So it's not something that we will be able to do as a country even on a regular basis from here. So therefore, for the amount of effort that has gone into it, I think it is only appropriate that we respect that those results.
Sir, regarding that 100 meter by 100 meter grid you have taken, did you do any convergence analysis?
All those things were done.
Okay, sir.
I personally have not done that study, but
Okay.
I assure you that all the standard procedures were, followed, and there were review committees, and there were, there was a separate subcommittee of CD39 which oversaw everything, and very eminent people were part of it. So all those things are taken care of.
Sir, last question. Regarding the overstrength factor, you told. So it's the ratio of the maximum strength to the yield strength, or it is the ratio
To the design force.
Okay, so it is the maximum strength to the
So
design
basically
force.
it is overstrength include, it is that.
In US code, it is actually the maximum strength to the yield strength.
I don't see. See, there are two ways this overstrength that we talk about is one is that from the yield to the maximum strength is basically due to redundancy in the system. That is what it happens. And from the design force level to the yield is what is generally called as the overstrength part. The point is, if you idealize it as an elastoplastic, then that peak and the yield becomes same. Then what you are left with is only the overstrength. So together these two are collectively called as overstrength, and that is what we are representing here.
Okay, sir. Thank you.
I just wanted to make a comment on the hazard map. I mean, I've been in the committee and I have the highest regards for the map makers, if I may call them that. But I think all of us must understand that, as Professor Goswami showed, that actual data from earthquakes, we have very, very little, okay? And we've picked up 60,000 points, okay? So how do some of these points come? Because I've personally gone through it and I've seen that. So I saw one of those points in certain scripture, they have described that this event happened and the earth shook and this happened and that happened. So then the person who's read it says, okay, so it was an intensity of 8. So if it was an intensity of 8, then I will assume it's a magnitude of so and so. Now what happens across the world when they make these kinds of maps? What they do is they have somebody who prepares that and says that, this is what I interpreted. Then there's somebody who peer reviews it. Okay, so there's a lot of rigor. I mean, I think there used to be one, there is a project which is called a GEM project. I don't know if anybody of you know, it's called the Global Earthquake Model. And if you see the rigor, so they will, when they're looking at the Indian subcontinent, they don't have 60,000 points. Because when they are looking at the point, they want very robust points. So when you have points which have been picked up, which, it's my interpretation, if somebody has written this in some scripture, that this is this, whether I think the intensity of that was 8 or 7 or 6, is my personal interpretation. I'm just pointing this out to you because there is a lot of such. The science is not 2 + 2 = 4. Okay, it's a lot of history in it, it's an interpretation of history. So, to be fair, the people who prepare these kinds of documents do a lot of work. But in the end, history is his story. His is very, very important. And I think that's one of the reasons that all of us must look at these numbers, must look at these things, and also use one's judgment also. So the point which I'm trying to make, there's no doubt in my mind that if you're looking at the Himalayas and you're looking at the base of the Himalayas and you're seeing the thick alluvial belts over there and you're seeing the kind of amplification which can happen there, there's no doubt in my mind that, yes, things can happen in the northeast, it can happen in some parts of Kashmir, some parts of the base of the Himalayas. Then when you come down, we are in the Deccan Plateau. We are really in the Deccan Plateau, and sometimes, yes, we've had up to the maximum. We had a reservoir-induced earthquake in Koyana. But we are talking about the maximum. We are saying is about 6.6, 6.7. We are not looking at 7 and 8. So the difference, for example, if I'm looking at Ahmedabad, which is also in Zone 3, and I'm looking at Mumbai in Zone 3. I don't think those two zones are the same. I think that Ahmedabad, with the kind of soils which it has and the kind of you know, it's right there in front of us. 2001 is, everybody remembers that. So I think that there are issues which we must understand, that even hazard maps are consensus documents. You know, it's not like everybody agrees to the same thing. But this is the best estimate for everybody to be put together, right? That's.
In fact, we had a situation where one event was actually changing the kind of hazard estimate that we had in a region close to Calcutta in West Bengal. And it was caused by one event. Eventually that was removed from the database, and then we got a much reasonable kind of a thing. So yes, these kind of things did happen along the course, and so that's why I'm saying, I mean, the uncertainties that are associated with these kind of work is huge, but this is the best that could have been done given whatever we have today in terms of database and everything else.
Yeah, very warm good evening to everyone. And my question will, after listening to from the day long this particular workshop, I have multitude of questions rising in my mind regarding where we stand and all. So out of that, I try to speak my mind on a couple of commentary and a couple of questions I have in my mind. So commentary would be like, say, since this particular we are sitting at the juncture of the time wherein the paradigm shift is going to happen in the design approach by the structural design engineers. So what I see that there is an increase in the forces. So the increase in force will cause lead to increase in the sizes of the structural members. So what I see in the social economic arena is that whatever the real estate area is going to decrease in the carpet area because it increases the member sizes, and probably that may lead to certain kind of litigation to your neighborhood because we have very shortage of the land, and that may your increasing the size of the member may lead to litigation in the neighborhood because your the member is going into their area or something like that. So probably the real estate cost could grow, probably go high into this force. So this is what I see the larger impact of this code rather than very much focusing on the technical aspect of it. So this is my commentary, and my question would be like when we specify the cover to any structural members, typically what we do is that in the whole all structural members for us we basically divide into categories of load bearing beams and foundations, and for these major three groups of structural items we specify the covers, but we never specify the covers for the internal members or the external members. So that would lead to greater durability for the structure as a whole. So what I would expect in the upcoming code is that the cover to concrete has to be incorporate kind of environment where that particular member is sitting in. So that has to be there. So whether upcoming code mentions this kind of what you can say cover to members based on where it is sitting in the structure rather than in general to overall. That is one of my question to the panel. Yeah.
Thanks. I think that's an important point, and there has been discussion on in that regard. We need to distinguish between members elements that are internal versus external. So that distinction is being made. Thanks.
So my second question would be that say nowhere in the code we mentioned that our structure is designed for so much of number of years, because what we talk about only is the number of return of period. Can we say that this particular structure is designed for say 475 number of years or only 50 years of years?
No, because there are two aspects to it. One is the service life, and that is basically fundamentally related to the durability aspect of it. So that's one part of it. And now from there we also then draw the conclusion. Therefore, and depending on what is the level of accidents level, for instance, for wind, for earthquake, or any other natural event for that matter, what is it that is acceptable? We take that and say that okay, therefore this is the return period. For instance, in all building code for wind calculation, there is it is clearly stated. What is that for serviceability check? What is the level of wind we consider? Right? For design, for strength design, what is the thing? So that is what we do.
So design life is based on what is the return period for the wind kind of thing? And
no, design life is not based on that. Design life is fixed, service life is determined, durability design has to be done to ensure that the structure remains serviceable for that, and then correspondingly for the other natural events, there is a call that is taken as to what is that level of thing that we do, and we connect it to the design life and see what is the exceedance level, therefore we are accepting in design. If that numbers appears to be okay, then we go ahead with that.
I guess my questions are over. But what I see is that definitely the story, kind of will be paradigm shift, since we are, looking these codes in 1400 pages, and after 40 years, it would, give a lot of, kind of anxiety as well as,
No. We will do it. We will collectively will do it. Don't get anxious. Don't get anxious. I think here.
While you are there, I wanted to thank you for the opportunity to ask you. Monthly writing, but we want to, restrict our stresses in columns
to 0.4 FCK, so that it remains balanced section, because the compression increases, it will become brittle. So why that clause is not, why we are not indicating that to walls? Why it is restricted to only columns? Because what we see,
If I'm not mistaken, and somebody can correct me, I think this came in the amendment.
we know it was supposed to come. I was waiting for that amendment, but it has not come in latest amendment.
Everybody thinks it's not come?
No, it's not.
It's
Okay,
not come.
I think because I remember that we discussed it in the amendment.
Yeah, even I was waiting eagerly that it will come, because again I am saying.
Okay, so that's a gap, because I was so sure it is there, because I know that in my, whenever all of us work, we make sure that it's also followed for walls, but good point, I remember.
Thank you, ma'am.
not for eight spaces, it's for only compression.
Okay, we are coming to the end of this session. So I thank all the panelists. I think certain very critical points have been raised by Anil Hira. Durability, sustainability and carbon footprint. That is also very, very important in today's life for all design of structures, that we must emphasize. And one more point is very interesting, that gut feeling is I think most important. That is I think pointed by Dr. Goswami also. And there is no substitute to good engineering practices, of course. So unless you have proper design, proper planning, proper execution, you are not going to get this success. That is I think the bottom line of all this. So I thank all the panelists, Alpa Madam, Dr. Goswami, and I thank the another speaker in the morning session, Jaswant Arlekar also, who has helped us. Dr. Goswami couldn't come here to represent it on India. So thank you very much to all the speakers and dignitaries. I must thank Director VJTI for making this hall available to us. Strategy Department VJTI who helped us for the arrangement. Similarly, I must thank all the staff of VJTI Auditorium catering who have given the excellent food, though we exceeded the capacity. So I must thank all the participants also for the overwhelming response, because the registration has crossed 200 mark, because the capacity has been 200. I thank you all. I thank all my colleagues in ISSC trustees, the sponsors, Ultratech Cement, who has sponsored the event, and they are always helping us in conducting the event. So thank you, Ultratech. And again, I thank all the delegates who has come from long distances to attend this workshop, especially on the working day. And till evening 6 o'clock, the auditorium is full, so I am very happy about that. So I again urge, if you are not member, please become our member, support ISSC and support the fraternity. As said by Dr. Goswami, we have to come together, and then only we can evolve good engineering practices, good structures, good codes and good structures. Okay, thank you very much.
Okay.
रेड्डी सर को होना चाहिए था, सर को होना चाहिए था, आज क्वेश्चन